Welcome to my project bazaar.com. Let me discuss about the process constant modulus algorithm for peak to average power ratio reduction in MIMO OFDMA. If we see about the process constant modulus algorithm for peak to average power ratio reduction in MIMO OFDMA. So in this process we are providing a method to reduce the peak to average power ratio using constant modulus algorithm. In the first step, the OFDM signals were generated and they are transmitted. After transmitting, the time domain signals from the resource blocks may be linearly combined using the pre-coding weights transferred to the receiver. Next, the pre-coding weights can be designed to minimize the modular variations of the resulting signal, leading to generally reduction of the PAPR. In same way, we propose an alternative formulation of this problem by replacing the infinity norm by the average deviation of the OFDM blocks, so that the PAPR value is further reduced. The main objective of this process is to reduce the PAPR of the signal, and finally we are plotting some graphs which describes the comparison of the different CMA algorithms, that is UCCMA and STCMA, with corresponding to the input OFDMA signal which has high PAPR, and output signals will be having low PAPR values. First, initially the OFDM signal is generated. So OFDM signal is abbreviation for the orthogonal frequency division multiplexing. This describes a digital modulation scheme that distributed a single data stream over a large number of carriers for parallel transmission. These carriers are called as the subcarriers of the signal. In the frequency domain, they are equally spaced around a central RF carrier. The primary advantage of OFDM over single carrier schemes is that ability to cope with the several channel conditions. Channel equalization is simplified because OFDM may be viewed as many slowly modulated error-band signals rather than one rapidly modulated wideband signal. Then the OFDM signal is transmitted. OFDM block with subcarriers is transmitted from each antenna. Subcarriers will include useful subcarriers surrounded by two chord bands with zero energy. The useful subcarriers are further grouped into resource blocks, each consisting of subcarriers. Data of one or more users is placed in these orbits and then mapped into the space the time domain using an inverse discrete Fourier transform, and the space block time using coding. To allow the channel distribution to receivers, each orbit also contains several pilot subcarriers that access the training signal. Then in the receiver it is demodulated, so these processes is just like the modulation process. Then to the original OFDM signal, CMA algorithm is applied. CMA algorithm is a method to update the covariance matrix of the distribution. It is particularly useful if the function is still conditioned. Adaptation of the covariance matrix helps in the landing of a second order modulation of underlying objective function. In contrast to most classical methods, fewer assumptions on the nature of the underlying objective functions are made. Only the ranking between the candidate solutions is expected for landing of the sample distributions, and neither derivatives nor even the function values themselves are required by the method. Then after applying the CMA algorithm, PAPR value, so we are getting the CM signal. So the PAPR value of the original signal is also measured, and the PAPR of the constant modulated signal is also measured. PAPR is reduced by the reasoning pre-coding weights that minimizes the modulation variations of the resulting signal. The sequence descent CMA, STCMA, and the unit circle CMA, UCCMA algorithms were used. The STCMA is a block additive algorithm in which we act the full data matrix and update until it converges. Like that, the different types of CMA were also compared, and finally the results were compared and the graphs were plotted. Let me see the execution of the process constant modulus algorithm for peak to average power ratio reduction in MIMO OFDMA. If you want to run the code, select the file OFDMA which is present in the source code folder, right click it and select run file. So the process will be started and executed. So initially the OFDM signal is generated and the channels for the OFDM signals were allocated and the results were displayed. Then we are applying constant modulus algorithm to this. So for that, initially the original sequences is present, and then we are detecting the peak sequences alone, and then here this is the constant modulus signals applied process. So here we are getting the peaks values more constantly. So the PAPR will be absolutely reduced. So we can see that. So initially the PAPR of the original signal is 17. So we have getting up to 5 point like that, and the MSC is also calculated. So here we are plotting some graph. This graph represents the relationships between the original and the obtained uh, OFDM signal values. So we are plotting the graph based on all the types of the CMA algorithms, that is UC CMA like that. So here we are getting as a result these three graphs. This graph is drawn between the SNR values and the capacity bits that we got in the different algorithms, and we have compared that, and we have displayed it like this. And also here we have plotted graphs related to this SNR and the weighted rate value. So this graph is plotted and the result is listed like this. And then finally we have drawn a graph between the PAPR values and the CCTF values. So this graph is drawn like this. So this represents the PAPR values reducing for each different types of the CMA processes. Thank you.